Okay, welcome back to the IB Chemistry May 2025 TZ2 exam walkthrough. We're continuing on with paper 1B. In this video, we'll be covering question number 2 and all of its subparts. This is for SL, but HL also has the same question, so also watch. So this one is essentially with this experiment where you have some spinach leaves, you're boiling them for some various times, and then you are essentially testing for the presence of Fe2 plus ions by titrating with some potassium permanganate solution. It's a very common experiment. I actually made my own test question based off of this experiment, so feeling big brain right now. Anyways, part A, it basically tells you that you have 3 trials for each boiling time, and in each of them you have 10 grams of spinach in a beaker with 250 milliliters of tap water. You got 5, 10, 15, and 20 minutes for your kind of range. If spinach was then removed, you kind of did a little filtration to get the water, spinach water, and then bottled, stored until this titration was performed. And then part 1 tells you to state the independent and dependent variables. This is one where we have finally gotten an answer to this one question I've had for a while now, because in the subject reports, they've mentioned this for the IAs of, derived versus measured dependent variable. But they've just mentioned the difference. They've never, I feel like, said what they preferred, unless I'm blind, which I could be blind. I could be illiterate. I don't know. But I was never sure. And so in this one, it did clarify in the mark scheme. And so obviously, okay, the independent variable is the thing that you're changing. Okay. Everything else is the same except for this thing. You're changing it in order to measure something else. Okay. And so in this case, we have for each boiling time, you have 4 different boiling times. It's your boiling time. Okay. So the independent variable is the boiling time. Okay. And then for the dependent variable is you may want to say, which I also may have done this, is you may want to say is that, cooled and tested for the presence of Fe2 plus ions. So you may want to say the concentration of Fe2 plus ions. That is what you're calculating inevitably at the end. That's not what you're measuring directly. What you're measuring directly is the volume of potassium permanganate solution used. Okay, so this is going to be for our dependent variable, the thing that you're measuring in order to see what its effect of the independent variable is the volume of KMnO4 used. So that would be part 1, is that would be the independent and the dependent variable. I still see students struggling with identifying independent, dependent variables. If you don't know that at this point, I would go watch some videos. I would go do some little online quizzes. I don't know. There's lots of practice worksheets on them. Go ahead and just get that fixed, because it comes up every few years. And 1B is definitely a big one that they probably will ask about. For part 2, it says suggest 2 additional experimental conditions that should be controlled to ensure that the methodology of this investigation is valid. So this is one where I also got tripped up on this one when I took this myself, is all of the things that are mentioned already in the description, you can assume are relatively controlled to some extent. Okay. And so, for instance, things that I chose is I put like the concentration of the potassium permanganate, seems like a valid option. Things like, I don't know, I was like, like the temperature of like the water boiling. I don't know, like that felt right. And so none of those were on the thing of the list. It's a big old list, and it's all things that seem to be relatively things that they haven't mentioned in any shape, way, or form. If it's been mentioned, you can assume it's probably already been controlled. That's what I gathered from that. Okay. So 2 additional things that haven't been mentioned at all. We've already gotten they're boiled in water. The water was cooled, so you can assume that the cooling was controlled. The standardized potassium permanganate, so you can assume that the concentration is controlled, like the water or whatever. So some things that haven't been controlled is this is where you're imagining that stupid table you all put in your IAs. I hate it in a table form, but that's just me. Anyways, of all your controlled variables, you're thinking of what would go in there. And so immediately I'm kind of thinking, make sure I'm gonna put 1. All of the spinach is coming from the same source. Spinach is from the same source. Okay. So that would be one thing that you would need to control because you got it from different suppliers. I mean, are they even the same type of spinach? I'm not a biology guy. Like, surely there's different types of spinach. Like we want to make sure that they're the same type source. I'm gonna put and type just to be ultra specific. Okay, and then a second thing that you would need to control would be something like the KMNO4, okay, is things that would affect the results. Okay, that's what you're thinking of here. Is things that would affect the results. That KMNO4 is well known for being very light sensitive. And so store KMNO4 properly in dark bottle and use quickly because it goes bad very easily. So, and use quickly. Okay, so that would be another thing that you would want to control. There were a lot of options for this one that they accepted. I'll put a list here. These were all the options that they accepted. And you'll notice that not a lot of them have to do with things that are already in the description. So don't say those things. That's what I took from this for future reference and future exams. Whenever they're talking about control variables, if they've already given a little detail on it, you can assume it's relatively good controlled. Okay. Okay, so for this question 2 for this part B is we have a nice graph of our average results. And so we have the amount of Fe here and then the boiling time here. And so we have it from 0, 5, 10, 15, 20, and 25. And so the first question is to state the relationship shown the graph between the amount of Fe2 plus released from the spinach and the boiling time. As you can see here, not much changes. If it were linear or a positive correlation, it'd look like, or at the very least, like a, but no, it's also not negative either. It's not like, or like, literally like all of them but one are 0.8. So there is no relationship. None. No relationship. It's a trick question. Trick. Okay. Part 2 is to comment on the range and the quantity of the measurement used in the investigation. So the range essentially refers to the range of going from 5 to 20 for our cooking times. Okay. And so in this case, you could essentially kind of comment on that range. And so like 5 to like 20 these are very realistic for how long someone would actually spend boiling spinach. So that could be something that you would comment. That's the first thing that comes to my mind. So I'm kind of going range here. I'm kind of denotating both as range and then quantity because there's 2 marks. You can obviously tell that's where both of those marks are going to come from. Okay, so range is that the range of cooking times is realistic for the kitchen. We'll say that. Okay, so that's what I'm saying. Meanwhile, you have the quantity, and so the quantity is there's 2 ways that you can look at this. You can either actually there's more than 1 or 2 even actually is there is the range of like how many variations of your independent variable you have. So in this case, we have 1, 2, 3, 4. Okay. We don't even have 0. We also don't have 25, even though those are on the axes. We only have 4 different variations. And so that is not enough to prove a trend. That is another thing that they talk about in the IA subject reports a lot of the time, is that for the quantity, so there is not enough time variations to prove a trend. Prove a trend. Okay, so like even we say no relationship, even because we have only 4 different intervals, there's no way for us to prove that with confidence. Okay, another way you could have interpreted this is the number of trials. So in this case, it says 3 trials. You could have said that was enough replicates. You could have said something like that. You also could have said, I'm trying to remember what the other one was, where it was something along the lines of, let's see, where it was about the t equals 0. That was something you also could have commented. I'll put a copy of the mark scheme there so you can see what all your options was. There was lots of them. Paper 1B, as you may notice, is just a million options for all the possible answers. So that's why I say my advice is just say as much as you can. As long as you're not contradicting yourself, you're more likely to hit at least one of them. So there's that. For part C, you have that the initial hypothesis was that more iron 2 plus would be extracted as the boiling time increased, a reasonable hypothesis. And it said whether or not this supports the hypothesis. And this says with a reason. There's only one mark. Okay. So you have to both say yes or no, but you have to give a reason. If you just say yes or no, you guess without a reason, or your reason is wrong, then that will not give you the mark. Because there's only one. So it's going to be blank and blank. It's not going to be two separate checks. You have to have both of them in order to get the mark. Okay. So our hypothesis was more whatever. And so we're going to say no because as the times increased, also I'm going shorthand here. As the times increased, the Fe2 plus extracted stayed the same. At 0.8 ish each time. Okay, so that would be that one. Sorry, I'm like iPad kid coughing. I'm writing on my iPad. Anyways, part 3 is to suggest one modification to the investigation that would make it more suitable for testing the hypothesis. This is what I mean when I say this is like the IA and test form. This is literally your evaluation section. Anyways, and so one modification that would make it more suitable, is the big one here would be to add another interval, and therefore the most suitable one would be that t equals 0, because then that would also serve as essentially your control, because you could see whether boiling it in the first place does affect things. So that would be testing the Fe2 plus without boiling at all. So that would be one. You also could have done other types of techniques, kind of like, I believe, what's it called? There was like atomic spectroscopy or something. That was an option. I'll put the mark scheme here, just like I normally do. So those were all your options, lots of them. And so that was question 2 for paper 1B.